Hello friends, welcome to Foxview Tech. So we have seen more about Kubernetes and a lot of basics on depth view of what is happening beyond the scene. So part of that today we're going to see about Kubernetes deployments and we'll see what is happening beyond the scene whenever we do deploy any applications. So deployments are the critical aspects of managing your applications in Kubernetes. Why the process may appear simple at first glance because we're very familiar with that and we think like it's easy to do that, but a deep understanding about the internal workflow is a very crucial for troubleshooting the issues and optimizing your deployments, right? So let's jump into this. So initial deployments, how do you deploy your applications? There is a multiple ways. Either you use a YAML or JSON file, and the common most approach and applying the files containing the deployment manifest using the kubectl apply. Or you may run a kubectl run command, simplifies the deployments by providing the image name and basic configuration through the command lines. Or you may use kubectl create command, offers a greater control by simplifying the details about deployment parameters like a replica set, blah blah things, right. So now let's assume like you have deployed the file either one of this method, and what happens, there is two operation involves. One is on the client side, one is on the server side. What happens on the client side? The validations. First thing, it ensures that resource type and group and client credentials are valid. Then it's check the context of and authentication, and it's extract the current context and the cluster name and authentication information from the kubeconf file, and it's make HTTP request forms and send the deployment request to the HTTP server, right? Then client side operation is done. So now it's moved to the server side. What happens on the server side? So server side, as I said, you are deploying your application, run the kubectl command by the run, apply or the create, and you paused it and API server request received the request, right? So here there is a various actions done. The first step is authentication and authorization. Part of authentication, it verifies your client credential using certificates or token or basic authentications, or author, and then the authorization comes to that evaluate your user privilege using RBAC, ABAC or webhook or whatever the things you do, right? So first step is authentication. Next there is a major section, it's come to the play. So the case is right, and then it's called admission controller. So to give more detail about admission controllers, so as we are using widely the Kubernetes and deployment spot service constantly comes and goes. But before any new objects enter the cluster, it must pass through critical checkpoints, uh, right? So that's how the admission control takes. Let's assume the admission control as a gatekeeper for the Kubernetes cluster. It meticulously examines every request, creates updates or deletes objects, ensure that it complies with your defined policy and security standards. It's if any request fails to meet the criteria, it denies the request and safeguarding your cluster from potential harm on the misconfigurations. So let's me give a detail like somebody is not having access, they are coming to your cluster and they are trying to delete your deployment. So admission control makes sure the user is valid or he has a potential access or valid, he meet the policies whatever it's been defined, and it performs. Or let's assume someone is trying to deploy the application with a root access that is very harmful and it's not recommended in any production environment. So in the policy control admission controller, the policy you can define no root access should be granted, right? So this will make sure you are not allowed to do this any of the actions. So how it works, it's there is a two types of admission controllers. One is like a mutation, and this controls modify the object before it persists to the etcd, essential shaping the objects to compile with your rules. And then it goes to the validating. Those control act as a gatekeeper, as I said, and preventing non-compliant objects from entering the cluster. They analyze the object and return an error if it's violate the any configuration rules, right? And what is the benefit of the admission controller? So it's enforce the security policy. You can enforce security policies and defining the specific rule to prevent unauthorized access or resource limitation or the security vulnerabilities, and maintain the constant configuration, ensure all the objects adhere to the your chosen standard for resource usage and labeling and annotations. Implement custom validation, build your own admission controllers to address the unique needs and enforce the custom policy. It's very much important for the very large cluster or organization level if you're maintaining any clusters. So this is a valid thing, and this is a correct place you can take a full control about your deployments or any actions happening on your clusters, right? And what is a popular admission controllers? So one is like a resource quota and enforce the resource limit and prevent the pods from the exceeding CPU, memory or storage constants, whatever you are defining. And pod security policies define security policy for the pods, restricting their capabilities and the resource access. There is a few more like a namespace admission controller and validation webhook allows you to what is validation webhook? It's allows integration with external webhooks and a custom values like you can integrate with a OPA, open source policy agents, or the Coverno. There is a new policy agents, so you can integrate those and it will be help you to manage it. Right. So you can make use of that, and that takes care by the admission controller. And then once everything is valid, then it stores the data to the etcd and position stores the data to the etcd. Then there is a major things like a controller. So here the controller, not only the single controller, there is a multiple controllers. First of all, what is controllers? So let's assume like your controllers are like a control loops constantly watching your uh, cluster for any changes. This is a place it will keep on check your cluster changes, and they compare the current state like whatever it's already I'm run. Let's like I'm running a single pod, or there is a deployment, and is it the same thing I should do, or is there any new change has been persisted, or there is completely new request has come to the cluster, right? So the controller keep monitor and it takes all the required actions. What are the types of controller we have? So there is a multiple controllers here, but when you do the deployments, there is a three controllers involved. First is deployment controller, which watch for the deployment events and ensure that specific number of replicas and running it's running healthy like that. So whatever the defining on the deployment file, it makes sure that the deployment defined as how many replicas it's all created, and the associated parts are very healthy, right? So first it watches for the deployment event. Then once the deployment event is received, it's pass the request or it creates a replica set. Then replica set will be monitored by the replica set controller. It's make sure that it's scaling the deployments and it's create the pod objects. So let's say like you are saying like I need a two replicas for the particular pod. It's the replica set creates a pod object. Hey, this is what the new request I got. Now once the pod request has been create pod object has been created, then there is a pod controller will come to the pitch. So it's monitor the pods, and also it's do lot of things. Part of deployments, it's check the pod controllers. Okay, there is a pod object has been defined. Now it's my job to create the pods, right? And it creates the pods. So what happens? Complete flow of controllers. First, it watches for any events. Then it analyzes the events whatever it's received. Then it reconciles what operation I should do. Then it reports to the next guys. Right. This is a major role of controller. And once everything is set, then now there is a next player come to the pitch. It's a scheduler. Now everything has been defined. The pod manifest or the pod operation is ready. Then scheduler receives the request, hey, there is a new pod has to be created on any node, or any if there is a pod contains any particular anti affinity or any kind of affinities or node taint and tolerance or any special node selector rules, it will be validated by the scheduler. If it's find any kind of a node selector operations, it's define the pods, it's deploy the pod to the particular node. If there is no such a request, it's randomly fix available nodes again based on the node resource everything. Then it schedule the pod to the particular node. So the scheduler says, hey, there is a new set request. Then the kubelet will receive the request and it starts create the pod. So what other things happens when you do the pod deployment at last? It will pull the image and pod setup and start the container and monitor pod health and update the status to the API server. So beyond the scene, there is lot happens when you are creating exactly single pod. So that has been already explained in the one more video, like when you're doing a kubectl pod creation, what happens. So I will attach that video to this video. You can refer and you can understand what happens exactly when there is a pod creation happens. This is very high level, but beyond the scene, very much detailed explanation has been given already. You can take a look if you like to. So this is what happens on the server side. This is all the operation done. So why it's important to understand all these things? So proactive troubleshooting. So whenever you see any error on any stage, you can easily understand if there is a something failing on the webhook. Okay, there is admission controller is blocking this. I have to do this. Or there is authentication error. You can easily go and fix the authentication issues. Or let's assume it's coming on the scheduler side and it's not matching any tail tolerance, or the node is not available, in the sense it's a scheduler issue, or the pod definition has some kind of issues, right? So then you can see like, okay, pod, there is some kind of a taint and tolerance name is missing, or it's mismatching, or it's wrongly defined. You can correct and you can fix it, right? So that is helpful. And also there is a further more issues may come. So those issues we have explained on our Kubernetes troubleshooting series with the multiple error logs, error messages. You can take a look once. And improved configuration, tailoring the current specific deployment needs. You can tailor it like if there is a high, like a particular set of nodes, taint and tolerance specified deployment you are making, so you can tailor it with the proper configuration, or something you want to improvise, you can improvise it. Next, automation, some kind of automation you want to make. Hey, I want to understand about complete deployment, I want automate via any kind of a tools. Let's assume you are using a Jenkins to add ad hoc mode deployment you are making, or any tools. Nowadays there is a lot of deployment tools, automation tools are coming. If you like to automate it through that, this and this, hopefully this may help you to automate it. And understanding this, you can grant a create control of over the your application and ensure that all the operations are smooth, right? So very important for any to not only the deployments, as we are telling from the other explanatory videos, like it's everything you should understand little bit depth, so that may understand help you to fix the issues or taking any control. So you may say like, hey, we don't need to scratch your head for the basic things. So this kind of understanding, it's very much important. So hopefully this video helpful for you guys. So if you like, please like and share with your friends, and stay tuned for the more videos. We hopefully will come up with a more interesting video for you. Thank you for your time. Have a great day. Bye bye.